Everyone. Today we're going to wrap up Chapter 1 and talk about scientific notation. So scientific notation is a really easy way to write large numbers or small numbers. So for instance, humans have an average of 100,000 hairs on their scalps. And this is a pretty large number. So sometimes it's easier to write those numbers in scientific notation shown here, where instead of 100,000, we write 1 times 10 to the 5th. Now another example is each hair is about 8 times 10 to the negative 6th meters wide. So that would be 0. Let's see. There we go. So each hair is 0.000008 meters wide. And this is a lot of zeros. So instead of having to write out all of those zeros, we can write 8 times 10 to the negative 6th. So numbers that are written in scientific notation have two parts. So you might have noticed that there's a coefficient and then a power of 10. So as an example, let's write 2,400 in scientific notation. Now, this is a number where it's not that large. You could just write it as 2,400. But later on, when we learn about significant figures, we'll find that sometimes writing numbers in scientific notation is useful because it indicates how many numbers are actually important in a measurement. So we'll talk about that later. All right, so if we want to write 2,400 in scientific notation, we need a coefficient that is in between 1 and 10 or equal to 1. So let's say our coefficient is x. It needs to be greater than or equal to 1 and then less than 10. So for 2,400, we're going to need the coefficient to be 2.4 because that is in between 1 and 10. All right, now we're also going to try to figure out how many powers of 10 we need. So because we have at least 1,000 in this number, 1,000 has 3 zeros in it, so that will equal 10 to the 3rd. Or another way to write that is 10 times 10 times 10. So the power of 10 is 3. And we'll see a different way to figure out scientific notation as well. This is just one way to figure it out. All right, so our final scientific notation for this number is 2.4 times 10 to the 3rd. All right. All right, so another way to determine how to write 2,400 in scientific notation is to imagine that there is a decimal point at the end of the number. Now, again, we're going to figure out the coefficient the same way we did before. It has to be in between 1 and 10 or equal to 1. And then to figure out the power of 10, we can just figure out how many times we have to move the decimal place in order to get to our coefficient. So in this case, we had to move the decimal point 1, 2, 3 times in order to end up with a coefficient of 2.4. All right, so that tells us that we have a power of 3 on our power of 10. All right, so we end up with the same thing we did before. Now, what if we have a small number like 0.00086? So, in this case, we have to move the decimal place 1, 2, 3, 4 times in order to get to a coefficient that's in between 1 and 10, 8.6. So if we have to move the decimal place 4 places, that means the power of 10 should be 4, except in this case we have a really small number. So actually, the power of 10 will be negative. So that's another thing to note about scientific notation. So the, let's see, so if you have a larger number, then the exponent, or the power of 10, will be positive. If you have a smaller number, so something with a decimal point, and the actual numbers are past the decimal point, then the exponent will be negative. The other way to think of this is if you have to move your decimal place to the left, as shown in the first example, then the exponent will be positive. So we could even put that up here. So move decimal left. And then if you have to move the decimal places to the right to get to your coefficient, then the exponent will be negative. So there's a couple of different ways to figure out what your exponent is, whether it's positive or negative. So in your textbook, there are a couple of tables that show some powers of 10. So in table 1.2, we can see positive powers of 10. So earlier we saw the example of 1,000, which is 10 times 10 times 10, or another way to write that is 1 times 10 to the third. We can also look at 100, which is 10 times 10, and that's 1 times 10 to the second in scientific notation. Now, you can also express powers of 10 if you have, let's say, a single digit. So 1 doesn't involve a power of 10 really, and the way to express that is to write 1 times 10 to the 0. So anything raised to the exponent 0 is equal to 1. And then if we look at just the value 10, there's only one 10 there, so the scientific notation would be 1 times 10 to the 1. And then there's also a table showing negative powers of 10. So you'll notice that these are all values that are past the decimal point. And then you'll also notice that we can express those values as fractions. So starting with 0.1, the 1 is in the tenths place, so that tells us that if we write it as a fraction, it's 1 out of 10. And then we would express that with a negative exponent. So 1 times 10 to the negative 1. For 0.01, that's in the hundredths place, that 1. So we really could express that as 1 over 100, shown here. Or another way to think about it is we're multiplying 1/10 by 1/10 to give us 1/100th. So to express this in terms of scientific notation, we would write 1 times 10 to the negative 2, because we have two 10s in the denominators here. And then if we take it a step further, 0.001, that 1 is in the thousandths place. So it's 1 out of 1,000. Or another way to express it is we're multiplying 1/10 by 1/10 by 1/10. So that's 3 tens, each in the denominator. So that would be 1 times 10 to the negative 3. And we could keep going. So this is just another way to visualize how we're determining scientific notation. Now, again, scientific notation is really handy in chemistry because often we're dealing with either really large numbers or really small numbers. And in fact, let's say we were doing some research on the chickenpox virus. The diameter of the chickenpox virus is 0.0000003 meters. So it's very, very small. And instead of having to express or write out all of these zeros, we could instead write this in scientific notation shown below. So let's actually go through the process of figuring out that scientific notation. All right, so we have a decimal point here, and we know that our coefficient has to be in between 1 and 10 or equal to 1. So that means our coefficient should be 3 because that's in between 1 and 10. Now, in order to get to our coefficient, we need to move the decimal place. So we're going to move it 1, 2, 3, 4, 5, 6, 7 times. Now, we did move the decimal point to the right. So let's write that down. Moved decimal to the right. And additionally, this is a really small number. So what that tells us is that the exponent, or the power of 10, will be negative. All right, so our coefficient is 3, and then our power of 10 is 10 to the negative 7th because we moved the decimal point to the right 7 times. So you can probably see that in this example, scientific notation is a lot easier to write out rather than having to count all of those zeros as you're writing them. Now, in your calculator, scientific notation can be pretty tricky. Depending on the calculator that you have, there are different ways that scientific notation is displayed. So, for example, let's say that you have a value 4 times 10 to the 6th. Now, in your calculator, if you have a scientific calculator, there should be an exponent or EE key, and you might have to press shift or second before using that function. And this is a much easier way to write out scientific notation on your calculator. So in your calculator, you would type 4 EE or exponent 6. And then when you hit enter, your calculator will display your value in a few different ways potentially. So you might see a 4 and then a space and then 06, and that space is representative of a power of 10. Or the 06 might be expressed as an exponent, or your calculator might put an E in between 4 and 6. Now, what if you have a negative power of 10? So let's say your value is 2.5 times 10 to the negative 4th. You would want to type in 2.5 and then hit the EE or exponent button. and then the negative button, and then put in 4. And again, your calculator will display the scientific notation either as 2.5 negative 0.4 or 2.5 with the negative 0.4 as an exponent, or it will place an E in between the two numbers there. So I encourage you to pull out your calculator and make sure that you are entering your values correctly into your calculator. So you can test out 4 times 10 to the 6th and 2.5 times 10 to the negative 4th. Now, you can also enter these values as, for instance, 4 times 10 and then use the caret symbol, 6. And I do encourage you to use parentheses around the power of 10 to prevent any mistakes or miscalculations. So that's another option too if you don't have a scientific calculator with the exponent or EE key. All right, now down below is just another table showing a similar setup. So if your calculator, let's say, gives you a value and you need to write it in scientific notation, so let's say you've done a long calculation, again, make sure you understand how your calculator is expressing scientific notation. So for instance, if you have 7.52 and then a space 0.4, that tells you that your coefficient is 7.52 and then your power of 10 is 4. And then again, remember, sometimes calculators will put the 4, so the power of 10, in as an exponent. And sometimes calculators will put an E in between the two values. And same for this value down below. If you see a 5.8 and then a separate negative 0.2, that tells you that the scientific notation coefficient is 5.8 and the power of 10 is negative 2. Now, what if we wanted to express those values in standard notation? So let's take this a step further. So let's start with 7.52 times 10 to the 4th. So what I'm going to do is write the coefficient, and because the exponent or power of 10 is positive, I know that I have a large number. So I'm going to want to move my decimal place to the right. So it's kind of the opposite of what we were talking about before. So I'm going to move my decimal place once, twice, 3, 4, and wherever there's a blank space, I'm going to put a 0. All right, so that is our value in standard notation. So we have 75,200. And what about our smaller number, 5.8 times 10 to the negative 2? So I'm going to write out the coefficient, 5.8. And this time, because I know I have a smaller number, I'm going to move the decimal to the left. So again, opposite from what we did before. And I'm going to move that to the left 2 times. So once, twice. And then that missing space, I'm just going to put a 0 there. So that gives me 0.058. So that would be my standard notation for that value. All right. Now, scientific notation can be really tricky. So if you do have any questions, please let me know. Or you can also set up a meeting with someone at the Writing and Tutoring Center. And I believe I have links in the syllabus. And I'll post some links on our website as well. And then additionally, the MARC can help with any math-related content. So if you need help with scientific notation, either the MARC or the WTC can help. And of course, I'm here to help as well. So let's do an example problem. Let's write each of the following in correct scientific notation. So we have 64,000 for our first value, and then we also have 0.021 for our second value. So if you want to pause the video and try this on your own first, definitely do that. And when you restart the video, we'll go over the problem. Okay, so let's go over A, 64,000. So first, let's figure out what our coefficient is. And remember, the coefficient should be at least 1, but less than 10. So our coefficient for the first number should be 6.4. So that's in between 1 and 10. Now we just have to figure out what is the power of 10. Or another way to think of it is how many times do we have to move the decimal point. So let's put a little decimal point at the end of our value here. And let's see how many times we have to move that decimal point to get to 6.4. All right, so we're going to move this once, twice, 3, 4 times. Okay, so that means our power of 10 is 4. Oh, I accidentally zoomed in on my screen. Now, again, remember we moved the decimal point to the left, and this is a larger number, so the exponent, or the power of 10, is positive. So we moved the decimal to the left, and this is a larger number. So that tells us we have a positive exponent. Okay, so now let's get a different color here for the next problem, just so we don't mix up our values here. So for part B, we have 0.021. What is our coefficient? So it should be 2.1 because that's in between 1 and 10. And now we have to figure out what the exponent is on our power of 10. So let's see how many times we have to move the decimal point to get to 2.1. So that would be once, twice. So that was pretty easy. Now here we did move the decimal to the right, and this is a small number. So the actual digits here that are greater than 0 are past the decimal point. So this is a small number. All right, so that means that our exponent should be negative. So we would have a -2 exponent. So again, we moved the decimal to the right. And this is a smaller number. So we have a negative exponent. Okay, so hopefully that's not too bad. And here are the solution slides if you want to access those later when you're studying. And this really does step you through each step, so these are kind of nice to have handy. All right, so that is the end of chapter 1. We went through what substances and chemicals are. So we talked about matter. We also talked about the scientific method, so how to think like a scientist. And that involved going through some observations, coming up with a hypothesis, and then testing the hypothesis with experiments to eventually come up with a conclusion. Now, we did skip section 1.3, which was all about how to read the text, how to practice problem solving, forming a study group, but I'm going to let you read that section on your own. And I definitely encourage you to form study groups with others in the class so you can message each other, if you're willing to, and definitely work together on the homework and lab assignments. And then finally, we talked about key math skills. So we went through what place values are, we reviewed positive and negative numbers, as well as percentages and solving equations. We also talked a little bit about interpreting graphs, and we'll get more practice with that later. And then finally, we talked about how to write numbers in scientific notation. So next time, we're going to start chapter 2. We're going to talk about units and measurements. So I will see you in the next video.